Okay, scientist records the velocity of a particle from t equals 0 to t equals 9 seconds. So you can see in that time interval the velocity changes quite rapidly, okay? And then it says use the graph to estimate the acceleration of the particle at t equals 1.5. Now you've just got to remember with a velocity time graph, to calculate the acceleration, okay, you need to just work out what the gradient is, okay? The gradient is just looking at the slope of the curve, okay? So you can see here it's quite steep, isn't it? Okay, right? So in terms of the acceleration here, the acceleration is quite high, isn't it? Because very steep. But then when we look here, it starts to flatten out, all right? So it's less steep, which means the acceleration is not going to be so high, all right? Now at 1.5, we've got there, yeah, on the curve. Now to work out the gradient, what you need to do is you need to draw a tangent, if you remember, okay, that sort of mirrors the slope of that curve at that particular point. So when you line up your ruler against it, be careful, right? It's got to go in the same sort of direction of the curve at that particular point, okay? So we can see at 1.5 that the curve is sort of sloping in that direction. Okay, we're obviously doing this by eye, so yours might be different to mine, obviously. We'll try and get as perfect as we can. Okay, so I draw a tangent there. Now, in order then to determine the gradient, I need to draw a triangle, okay, on this tangent. So to draw a triangle, just pick two nice points. So I'm going to pick, say, this point here, because it sort of goes through nicely, doesn't it, at that point. It goes, it's at t equals 4 and the velocity is 9, so that's really nice. And let's see if we can pick that point there. I think, let's see if we can pick a nicer one that works for us. Let's just go with that one there. Let's make it that one there. Okay, so we're going to draw a triangle by joining up those 2 points by going across first, and then we're going to go up. Okay, so you can see here, the distance here then, the rise is going to be from 6 to 9, which is 3, okay? And then across then, when I'm going from 0.5, which is what that is, to 4, so that's 3.5, isn't it? Okay, 3.5 there. So that's what I've got, isn't it? Okay, and to get the gradient then, okay, the gradient is essentially the rise going up divided by the step across, okay, or the run across. So it'll be 3 divided by 3.5. Okay, that's what we've got there. Now they want this answer to 1 decimal place, and we've got to do this without a calculator, okay. So what I would probably do here is, first of all, maybe change this fraction so it's a bit nicer. So we'll double the top, so we get 6, double the bottom, 7. Yeah, we happy with that? Gets rid of the decimal, just double top and bottom. And we just got to work out then what 6/7 is then as a decimal to 1 decimal place. So bus stop method here. So 7 doesn't go into 6, so put a 0 there. Because we've got to carry that 6 over then, well, put loads of zeros here. Okay, so the 6 that gets carried over becomes 60. 7 then into 60 goes 8 times, okay, with the remainder 4, okay, because 7 times 8 is 56, so the remainder 4. 7 into 40 then goes 5 times, remainder 5, and we can stop, right, because they only want it to 1 decimal place. Decimal point up there, so you can see then 0.85, which would be 0.9 to 1 decimal place. Now in terms of the units, okay, we can put the units as meters per second squared.